Good morning, friends. This is Virat Kumar, lecturer in Electrical and Electronics Engineering from the Institute of Government Polytechnic, Vaddepalli. In the first semester of Electrical, we have an engineering drawing practice with a subject code of 18E106P, and today we are seeing about the subtopic from geometrical constructions. So today we will be seeing about engineering curves, nothing but conic sections. Engineering curves. So welcome to before going to the topic, yesterday we have seen about how to divide a line into some equal number of parts, and we have seen about how to draw tangents for equal circles and unequal circles, internal and external tangents, and we have also drawn arcs for with different measurements, and we have also drawn polygons, where a polygon is called three or more sides is called a polygon. So from triangle to heptagon we have just seen that the general method for all these diagrams. So we have seen all those things in the yesterday's class. We have seen very beautifully with a 30 minutes of video. I hope you have practiced well and just make in your sheets. So welcome to the today's topic. So engineering curves. So we will see a light introduction of it. Engineering curves is a curves which have been drawn from conic sections. So in this we have three types of curves. One is ellipse, other one is parabola, and the other is hyperbola. So there are three different types of engineering curves. So what's the first one? First one is an ellipse, parabola, and hyperbola. You can see here. So what is the first one? First one is ellipse, parabola, and hyperbola. Okay, ellipse, parabola, and hyperbola. Now the main today's topic we will be seeing is regarding ellipse. We will see today's session about ellipse. Okay, so how to draw ellipse, and how we'll see some methods in it. So it's just a slight introduction, and we'll just further see about how the ellipse looks, how a parabola looks, how a hyperbola looks. So and then we'll just step into making the ellipse with different methods. So what are the methods in ellipse? The first one is concentric circles method. First one is concentric circle method. The second one is rectangle method. Second one is rectangle method. The third one is oblong method. Third one is oblong method. Fourth one is arcs of circle method. Arcs of circle method. Fifth one is rhombus method. Fifth one is rhombus method. And the sixth one is basic locus method, and is also called as directrix focus. The sixth one is basic locus method, and is also well known as directrix focus. So in this session we will see how many methods we can complete in our session. We will just complete them, and we will see the further methods in the next session. Okay, this is the methods involved in drawing ellipse. So just make a note of it. So, I will erase all these things so that it will be very clear to you. First one is concentric circle method, second one is rectangle method, third one is oblong method, fourth one is arcs of circle method, fifth one is rhombus method, and the sixth one is basic locus method. Okay. We'll see the parabola and hyperbola in the next upcoming sections. So, we will see only ellipse for today, that too there are totally 6 methods in it. Most probably we will try to complete all those things. We will see how it happens. Okay, we will move on to the next slide. See, from these conic sections we have seen ellipse, parabola and hyperbola are called conic sections because these curves appear on the surface of a cone when it is cut by some typical cutting planes. So, why so these are called as conic sections? Because these curves appear on the surface of a cone when it is cut by some typical cutting planes. See, observe illustrations given below. See, this we already well know that this is a shape of cone. We mostly see in a birthday cap. So, if we cut it inclinedly, see what is saying, section plane through generators. If we just cut and if you see isometric view of it, it looks in this way. And the top view section, which is in pink color, is called as an ellipse. And whereas if it is cut in this way, section plane parallel to end generator, see, that means any one of the side of the inclined planes, then it looks in this way. The light green part is called hyperbola or parabola. The light green one is called parabola. If the same cone, if it is cut in parallel to the axis, say section plane parallel to axis, then it looks in this way, and that light green part is called hyperbola. So, have you got some differences between ellipse, parabola and hyperbola? So, how actually ellipse looks, how actually parabola and how actually hyperbola looks. So, for this session time being, you just leave about parabola and hyperbola, we just look only ellipse. See how, what is an ellipse? Section plane through generators. So, there is a cone over here, if it is cut the section plane through generators, then if you see the isometric view of it, so the top view part which is in a pink colored one, so that circle, it is not a complete circle, so that part looks like, that part is called as an ellipse. Okay. So, now we will step into some side. So, for this session you just note only this one, you just note only this thing. Okay, we will move on to the next slide. See, common definitions of ellipse, parabola and hyperbola. Sorry. See here, these are the loci of points moving in a plane such that the ratio of its distance from a fixed point and a fixed line always remains constant. So, now here the ratio is called eccentricity. ratio is called eccentricity, and it is denoted by capital E. What is saying? These are the loci of points moving in a plane which ellipse, parabola and hyperbola are. These are the loci of points moving in a plane such that the ratio of its distance from a fixed point and a fixed line always remains constant, and the ratio is called eccentricity, which is denoted by capital E. So, these denotes this value of ratio. If it is less than 1, eccentricity value is less than 1, then it is called for ellipse, and if the value of eccentricity is equals to 1, then it is called for parabola, and when the value of eccentricity is greater than 1, then it is called for hyperbola. So, for these three you can refer a problem number 6, 9 and 12 in the next slides. So, where loci points, fixed points and fixed lines. So, the best examples for this eccentricity value less than 1 is called ellipse, equals to 1 is called parabola, greater than 1 is called hyperbola. These are well illustrated in a problem numbers 6, 9 and 12. So, you can refer in that. When we will just move on to that slide, we will just remember these things. The second definition of an ellipse, it is a locus of a point moving in a plane such that the sum of its distance from two fixed points always remains constant, and this sum equals to the length of major axis. So, these two fixed points are focus 1 and focus 2, and refer problem number 4. So, you can refer a problem number 4 where ellipse by arcs of circles method. I think it is a fourth method or something. So, it is another definition for ellipse. What is another definition for ellipse? Just make a note of that. It is a, see this, it is a locus of a point moving in a plane such that the sum of its distances from two fixed points always remains constant, and this sum equals to the length of major axis. So, these two fixed points are focus 1 and focus 2. So, this can be referred from the problem number 4 where the ellipse by arcs of circles method. Just note this one and this and that. Okay, then we will move on to the next slide. Okay, so we will make the ellipse one by its methods. What is the first method? See, ellipse by concentric circle method. Okay, here we will directly step into the problem, so that if we just make a problem, you can understand the construction part also. So, there is no separate explanation for construction of ellipse and then we will try to solve a problem, not in that way. We will directly step into the problem, so that you will be able to make the problem and you will understand the procedure for drawing ellipse also. So, a problem number 1. Draw ellipse by concentric circle method. So, take major axis 100 mm and minor axis 70 mm long. Just note the problem simultaneously with me. Draw ellipse by concentric circle method. by taking major axis 100 mm and minor axis 70 mm long. Firstly, we will see some steps, the procedure to draw the ellipse. See here, you can see steps to draw the ellipse by using concentric circle method. We will see one by one. Draw both axes as perpendicular bisectors of each other and name their ends as shown. We will be seeing in the figure. We will just read it out all the steps, and then we will see the diagram. Draw both axes as perpendicular bisectors of each other and name their ends as shown. Second one, taking their intersection point as a center, draw two concentric circles considering both as respective diameters. The third one, divide both circles into 12 equal parts and name as shown. The fourth one, from all points of outer circle draw vertical lines downward and upwards respectively. The fifth one, from all points of inner circle draw horizontal lines in order to intersect those vertical lines. And the sixth one, mark all intersecting points properly as those are the positions on ellipse. And the last one is, join all these points along with the ends of both axes in smooth possible curve. Then it is a required ellipse. Just note down the steps. Okay, we will see the diagram as per the steps. So firstly, draw both the axis lines and name them on their ends. So this horizontal one is a major axis and the vertical one is a minor axis. Just follow. We'll see it again. Now from the center, with DC as dia, draw a circle and with AB draw another circle. These two circles are called concentric circles, and extend this line and divide the whole part into 12 equal parts. See, and name them. See, is it happened or not? 1 2 3 4 5, that's a 6 7 8 9 10. It's AB is 11 and 12, totally 12 parts. Name them in the inner circle also. Now from all these points of inner circle, draw horizontal line to intersect those vertical lines. See, already from the it is a straight line, vertical line, and from 10, from all the points 10 9 8 7 6. Okay, now again from the inner circle you draw a horizontal point in order to intersect those lines. Now mark all those points. Now join all these points along with the end points, ends of both axes, with a smooth possible curve in order to get a required ellipse. So this is our ellipse by concentric circle method. Is it clear? This is our ellipse. Shall we see it again? Okay. See it carefully. Firstly, then a minor axis, name them, draw the in circle and X circle, then extend this line, then divide into 12 equal parts and name them for the outer circle and as well as in the inner circle. Now from the outer circle draw the vertical lines from all the points. And now from the inner circle draw the horizontal line in order to intersect those vertical lines. Now mark all these points. And join with a smooth curve in order to obtain a ellipse. Is it clear? Just note it down. Just note it down roughly in your observations, then you can make neatly in your drawing sheets. Just take 2 minutes of time and note it down. So this is our ellipse. Okay, then we will move on to the Next slide. See, the next is again the ellipse by using a rectangle method. In the same way, we will see the problem steps and the diagram. See the problem number 2. Draw an ellipse by rectangle method by taking major axis as 100 mm and minor axis as 70 mm long. The value is the same as in the previous concentric circle method, but here the method is rectangle method. We will see the steps. There are lots of steps in it. Firstly, draw a rectangle taking major and minor axis as sides. Second one, in this rectangle, draw both axes as perpendicular bisectors of each other. The third step, for construction, select upper left part of rectangle, divide vertical small side and horizontal long side into same number of equal parts. Here divide into 4 parts. First you see the steps, then we will move on to the diagram, then you will be very clear about it. Fourth step, name those as shown in the figure. The fifth one, now join all vertical points 1, 2, 3, 4 to the upper end of minor axis and all horizontal points, therefore 1, 2, 3, 4 to the lower end of minor axis. Sixth step, then extend C-1 line up to D-1 and mark that point. Similarly, extend C-2, C-3, C-4 lines up to D-2, D-3 and D-4 lines. What is this? Then extend C-1 line up to D-1 and mark that point. Similarly, extend C-2, C-3, C-4 lines up to D-2, D-3 and D-4 lines. Mark all these points properly and join all along with ends A and D in smooth possible curve. Do similar construction in right side part along with lower half of the rectangle. Join all points in smooth curve, then we will obtain a required ellipse. So just take a while and note down the steps. See, all these are the relevant steps. Just note to make of that, all these. Just make all these things. Okay, then we will move on to the diagram. We will move according to the steps. So draw a rectangle taking major axis and minor axis. See, with the major axis of AB and minor axis of CD, we have drawn a rectangle. Again, in this rectangle, draw both axes as perpendicular bisectors of each other. We have got, and he said has to divide. See, for construction, select upper left part of rectangle, divide vertical small side and horizontal long side, vertical small side and horizontal long side into equal number of parts. He just said us to make into 4. We'll see. So totally 1 2 3 points, so 4 parts. Similarly the horizontal side, see 1 2 3 4. So divide these line into equal number of parts. We have seen in the yesterday's class how to divide a line into some equal in a given equal number of parts. So in that procedure you can make a division of line. Now he said us to what he said, now join all vertical points 1 2 3 4 to the upper end of the major axis. That means from 1 to D, 2 to D, 3 to D, 4 to D is already existing, and then extend similarly to the major axis and all horizontal points. See horizontal points, therefore 1 2 3 4 to the lower end of minor axis. Then extend C one line up to D1. C passing from one line extend up to D1. Similarly C2 passing up to D2, C3 passing up to D3, C4 is already at a point D. Now mark all these points at 1 and 1, at 2 and 2, 3 and 3, 4 and 4. Mark all these points properly and join all the along with a smooth curve. So repeat the same procedure. He said do similar construction in right side part along with lower half of the rectangle. This is the left part. Do the same procedure in the right side. D21, D22, D23, 4. So C1 to D1 extend, C2 to D2, C3 to D3. So mark the points, join the curves. So this reflects same in the lower half of the rectangle also. So then by joining all those points we will obtain a smooth curve. It is called an ellipse. So this is the required ellipse by using rectangle method. This is a ellipse. Is it okay? So shall we see it again? Okay. See clearly, AB major axis, CD minor axis, a rectangle, divide the left top rectangle part of vertical line and horizontal line into 4 equal parts, name them, then join from D to 1, D to 2, D to 3, D to 4 already is existing, then from C1 extend to D1, C2, C3, C4 extend to. So where it is intersecting, locate some points at intersection. So repeat the same towards the right side of the rectangle, the same procedure, and mark the intersection points and draw the smooth curve. So this procedure will reflect same to the lower section of the rectangle. So by making the same section we will obtain the same curve. So and this is the required ellipse. Just take 2 minutes of time and make the answer, make the diagram. Okay, then we'll move on to the next method. See, what is the next method? Ellipse by oblong method. Ellipse by oblong method. So here comes the problem number 3. Draw an ellipse by oblong method. So draw a parallelogram of 100 mm and 70 mm long sides with included angle of 75 degrees. Inscribe ellipse in it. So this is the question. What's the question? Draw ellipse by oblong method. Draw a parallelogram of, do you know the parallelogram? It looks in this way, parallelogram. So this is a parallelogram. It looks in this way. So he is saying us to draw an ellipse by oblong method. So draw a parallelogram of, this is 100 mm and this is 70 mm long sides with included angle of 75 degrees. So this angle may be 75 degrees, this angle. So inscribe ellipse in it. Okay, so before that we'll see this. We'll remove this. We'll remove this so that, so what is saying, the steps are similar to the previous, case. As a rectangle method, only in place of rectangle here is a parallelogram. So the rectangle method and oblong method is same, only the difference is there you will just observe a rectangle. Here instead of rectangle we will be seeing a parallelogram. So see, this is a parallelogram. Same way, I will just remove this red mark. A parallelogram of 100 mm and 70 mm long. Same procedure. The left top, divide the line into 4 equal parts and mark them. The horizontal part, mark them. Same from D to 1, D to 2. Similarly, C1 extend up to D1. And mark the, indicate the points at intersections. Repeat the same step towards the right top of the rectangle. Mark the points at intersections. Join the curve. The same reflects in the bottom end of the parallelogram. So here gets an, here gets an ellipse. Here gets an ellipse by oblong method. The difference is only just a parallelogram instead of rectangle. Instead of rectangle, we will just mark only a parallelogram, so that the angle of this is up to here, angle of this up to here is 75 degrees. Okay, we will see it again. I think for today we will be ending only with oblong method, since we have only 45 minutes. See it again. A parallelogram, so major axis AB, minor axis CD, left top 4 equal parts, 2 vertical line, similarly to horizontal line 4 equal parts, join D21, D22, D23, and same C1 extend to D1, C2 extend to D2, C3 extend to D3, and mark the intersections. Similarly, in the right top of the parallelogram, mark the intersections, join with a smooth curve. The same reflects in the bottom half of the parallelogram on either sides, left and right, and join these points with a smooth curve, so that is the required ellipse. Note it down. So this is an ellipse. Okay, see nicely, mark the points clearly, see the points clearly. If you miss these points, the curve also goes around, so the point should be same from C1 to 1 only, C from C2 to 2 only. You should not mark it over here. So mark the points clearly in order to obtain a smooth curve. So we'll see ellipse by arc of circle method in the tomorrow session. So this will be the end of today's session. So we have seen, so from this class you have got about conic sections. There are 3 types: ellipse, parabola and hyperbola, and you have seen some light introduction of it. And in ellipse you have total 6 methods. One is concentric circles method, rectangle method, oblong method, and We have seen some arc of circle method, rhombus method, and basic locus method. So in this session we have seen about concentric circles method, rectangle method, and oblong method. Since we have less time, we have only 45 minutes duration, so we have able to complete only 3 methods, and we will see the rest 3 in the tomorrow's session. Okay, so we have seen up to this. We have seen ellipse by concentric circles method, and we have seen ellipse by rectangle method, and we have seen ellipse by oblong method. So I hope you have got my point, and I have made very easy to you, and I hope you have made the diagrams in your observation notes and further make it in your sheets. So this ends the session. Thank you one and all. Have a nice day.